Birds and insects are masters of flight that can navigate through complex and dynamic environments with fascinating speeds and agility. Since they are constrained in their sensing abilities, they perform maneuvers to get motion cues and obtain more information about their environment. Our work aims to navigate a tiny quadrotor through complex and cluttered environments by mimicking exploratory maneuvers seen in bees called peering. These environments mimic the real world by containing arbitrary gaps, static and dynamic obstacles with no prior knowledge of the scene components, their locations, or ordering. We induce an exploratory motion of the drone inspired by peering and obtain pixel movement or optical flow and its uncertainty. This active vision based approach helps us get a more robust optical flow and uncertainty prediction. We use this flow prediction to find free spaces in the environment. Finding the largest free space is pivotal in static obstacle avoidance and gap navigational scenarios, since it provides the target direction for safe navigation. We observe that static objects which are closer and fast moving objects approaching the drone exhibit similar high optical flow values. To distinguish between high optical flow of dynamic and static obstacles, we leverage the uncertainty of optical flow prediction, which is higher for dynamic objects. We experimented in various scenarios with different setups and scene ordering and obtained an overall success rate of over 70% with the algorithm being trained using only simulated data. To the best of our knowledge, this is the first work that handles all such scenarios together using a monocular camera without explicit depth information and using only onboard sensing and computation. Our work can unlock autonomous abilities which were not possible before on tiny robots.